Okay, great. All right. I'm starting right over. My name is Vishal Reddy. I've been an Android engineer most recently, and before that, I've been in backend and data. Recently, I've come on to Hilton. Been a senior lead Android engineer there. It's only been a few weeks, so it's been fresh for me. But that's my LinkedIn, if you're interested. Courtesy note, I represent my own views and not my employers. So everything I say here on out. Does everyone have to do that? Yeah, I figured, yeah. All right. Okay, so like I said, I've been across the world in the JVM, and this has been a very unique experience for me in the Android world. If you've kind of been a Java developer in your life before, there's a good chance that you are UI challenged. What I mean by that is there's a good chance that as a Java backend developer, you start to see that CSS and that JavaScript, and you just kind of, close your ears and want to comfort yourself. And that's the reality that most of us face as Java backend developers. But it doesn't really have to be that way. Okay, design and UI can be a highly structured and highly type-safe discipline when applied correctly. Okay. All right. So what do I have to say to you today? Simple. Kotlin multi-platform and Compose represent a significant advancement for web frontends. Okay, a significant advancement for web frontends. What am I not saying? I am not saying that this technology is production ready for a large-scale app. Okay. I am also not saying that Compose WASM, which I will introduce soon, is the bee's knees, right? I am not saying that every tech talk that exists has to be purely promotional marketing material for what you're about to present, okay? There are some tech talks that you can simply enjoy a technology for what it is, benefit from it, draw inspiration from it, and make that for a future. What I'm really trying to say once again is this. Kotlin multi-platform and Compose mark a major paradigm shift in the modern web. Anybody use Kotlin yet here? Okay, awesome, yep. Use case, what's your use case? Android, something else? Yeah.
Oh, I used but not in production, at work. I used only, actually I started it a few days ago.
Yeah. Okay, awesome, yeah. All right, so Kotlin's a multi-paradigmatic programming language on the JVM. It embraces multiple paradigms, and it more or less has them cohere in a very ergonomic fashion, okay? It's designed for multiple domains, but also ecosystems, okay? Kotlin is not really only a JVM language, okay? And that's why I say JVM and beyond. Now you can use Kotlin with native performance in mind. You can use Kotlin well beyond its original intention. And that gets us to the question of what Kotlin multi-platform is, okay? Kotlin multi-platform, or KMP, is a technology that allows a developer to share business logic while targeting Android, iOS, desktops, and the web. And it does so with the goal of pursuing high performance and ergonomic API design. I don't know, oh. Okay, well, you can't see that. But this would have just been an image just showing you the different Kotlin targets. So meaning that you can write Kotlin once and have shared business logic for Android and the like. Android, iOS, desktops, and the like, okay? Okay, so how did we get here? And what I mean by how do we get here, the real question that I'm asking from a web front-end perspective, in the year 2025, where everything is React, everything is Svelte, everything is Solid.js. Does anybody use Solid.js? No, okay. I think it's great. We got here in a very roundabout way. Okay. In reality, the web has evolved historically in the form of cycles. We often start in a certain direction, deviate a little bit, and return back in a completely different direction. Okay. In many ways, this is much like a history of philosophy, right? So, if you ever taken a history of philosophy, there's a group called the pre-Socratics. Okay, these are philosophers that have existed before the time of Socrates, pre-Socratic. Okay, and many of these philosophers were noted for their view of what's called materialism. Okay. I have a point, by the way, in all this, so just stay with me here. They believed that matter was the origin of everything in the universe. Okay, now each one of them described this in a different way. Okay, it really wasn't until Aristotle, Socrates, and Plato that this prevailing view of matter being the beginning of the entire universe was virtually unchallenged until their time. Okay. So Xenophanes, Heraclitus, Anaximenes, Thales, Anaxagoras, and for them, the different points of matter were these: earth, fire, wind, water, and nous. And if you were from the 90s, if you grew up in the 90s, you know what that makes me think of? Captain Planet. Anybody a 90s kid? Ever watch Captain Planet? Yeah. Earth, fire, wind, water, heart. Yeah. Okay. Anyways. What's my main point? Thoughts and paradigms often undergo cycles. Thoughts and paradigms often undergo cycles. That's true with most things, even in the area of software development. And to some extent, history often repeats itself. How do we see this? Okay, quick image on the history of web front ends, right? The early 90s, you had HTML, CSS, and JavaScript, and you also did have server-side rendering, right, early on. So you would use, PHP, JSPs, I think you had ASPs in the 90s, right? All right, yeah. So much of the dynamic web in the early 90s was probably server-side rendering technologies, okay? Slowly, you begin with the arrival in the mid-90s with JavaScript and jQuery and some variations. These were very flexible technologies that allowed you to make client-based requests directly on your rendered page and then respond directly in the page. Okay. That was huge. That was amazing. Does anybody remember Flash? Okay. Flash was the bee's knees. All right? Flash was the bee's knees. The reason why I say that is because Flash actually unleashed an entire era of creativity in the web. Okay? ActionScript, I think, was the basic technology, but you would basically be able to have a mini applet inside your web page in the 90s, and you could play games on it. You could do all kinds of things. Now, this thing was totally insecure and totally problematic in so many ways. And I think the web consortium and everyone else who was involved in basically bringing it down. All right, I understand that. Right. Okay. You see further along the history of front ends, you do see the rise of AngularJS. I don't know, early 2000s or so, somewhere around there. AngularJS was interesting because to an already object-oriented world, it provided a way to do front ends in a way that was manageable, multi-modular. You had controllers and things like that. It was a very interesting era, very familiar conceptual model to most backend developers. So that was really interesting. AngularJS became, at some point, very difficult to maintain, and suddenly it declined in popularity. Okay? And soon you had the rise of more functional style web front ends, right? With React, I consider Vue one of those as well as Svelte and SolidJS. So necessity being the mother of all inventions, in some ways looking back into the history, paradigmatic software development, functional programming ultimately solved many of the maintenance problems that most developers were facing with early front ends, especially in dealing with very large applications. Okay? What's very interesting about many of these technologies, I'm gonna point out React in particular. You ever heard of Next.js? Probably, okay. Next.js exists because pure client-side rendering has its own issues. Okay, there are times and places where server-side rendering actually offers a great advantage. Okay, so really, Next.js splitting some of the logic between the client and the server, it's kind of a tip of the hat to the JSP and PHP era. Okay, again, paradigms happen in cycles. Okay. Was all this a little overwhelming for a Java track talk? Okay. Why should you care about KMP? And I'm going to introduce Compose as a Java developer. Compose is a front-end UI framework that is sort of agnostic and generic in the Kotlin world, mostly embracing functional programming paradigms. But having Kotlin as its underlying foundation provides exactly what it needs to expose a manageable UI to a Java developer who is UI challenged. Okay? It's somewhat easier for a Java developer to touch Kotlin and also Kotlin's tool sets than it is for a Java developer to wrap his head around React. I don't know, like when I first started interacting with JavaScript front ends and dealing with HTML and CSS, one of the things that I really struggled with in that whole paradigm is the fact that I always had to interact with multiple programming languages, right? I had to switch context over and over and over and over, okay? Context switching in software development is expensive, right? Much of what we do is think. We're paid to think more than we are to type, okay? And the more things that invade our holy grail of our thought life, that contributes a serious problem to our developer workflow. Now, in many cases, we just overcome it and we just deal with it. We don't have to deal with it. Okay? One of the things I wished when I'd first learned HTML and JavaScript, why do I even have to write HTML? Why do I need open and closing tags to write UI? Is there another way I could write it? And that's what Compose gave. Before we get there, HTML templating, right? You see some examples of these. On the left, you see like a JSP, and you see a little for loop there. On the right, you just see, a React template. It is wrapped in a function. It's emitting templated code, but is that really necessary? What if you could write UI code that was just in the native language that you were dealing with, and you didn't have to mix HTML, CSS, and JavaScript while writing a web front end? That is what Compose and Kotlin multi-platform can offer you today. This gives me anxiety. But this is an advanced tool set. This is Tailwind, right? In the CSS world. Okay? Maybe many of you can parse this reasonably quickly, but I greatly struggle with parsing something like that. Okay? So what is WebAssembly anyway? This is the wrong slide for it, but ignore the slide for a moment. Okay? WebAssembly in the browser, because you can actually have WebAssembly in multiple places, right, is a low-level bytecode for the browser. Okay? You have it basically in a canvas, right? You have like a mini app inside the browser. What does that remind you of again? Flash, exactly, okay? but it doesn't have Flash's security problems. WebAssembly is crazy fast because you're dealing with a lot lower level bytecode than you would be, okay? So a CPU processing heavy task, WebAssembly is gonna beat JavaScript by a long shot, okay? What's interesting about WebAssembly is it's had a struggle with adoption over the years, and mostly because of Safari. Safari took a very long time to finally fully support WebAssembly. But it's here now. It's more or less here now. But if you're on an old iPhone and you still have your version of, you're trapped really, right? But just remember the very interesting, innovative offerings that Flash as a technology offered. That is entirely unleashed with Compose multi-platform. You can write all of your UI in one language. You can share your UI between Android, iOS, desktop, and the web, okay? Now, to conceptualize this as a Java developer, I don't want to get back in a situation where I have to write all my UI like this. That is not the life I want to live, okay? I'm used to building very component, reusable UIs where I don't have to write much custom UI code every second of the day, okay? And I get that with the ecosystem that Compose multi-platform offers, okay? Now, Google has this thing called Material Theme Builder, right? Now, if I were UI challenged and I didn't know how to write really accessible UIs and CSS and things like that, okay? What I could do as a Compose multi-platform developer is go to this website, and go to the theme builder. I can pick a few colors on the theme builder, and it will auto-generate very accessible contrasts for all of my UI components, okay? So that the next time that I basically declared button with no styling whatsoever, it's going to use the exact same styling that was selected in the Material 3 theme generator. I don't have to write my UI over and over again. All I have to do is call a function that says button with a callback and all that jazz. That's insanely awesome. I can write all of my UIs in one language and not have anxiety. All of my components are going to reflect the exact UI that was designed in the original architecture without me having to worry about it. And let's say I wanted to make very custom modifications. I could. We have modifiers, okay? This is just a little text view, okay? The value that you'll see in the text is hello world, okay? And fill max width just brings that text field to the max width of the screen, or at least its outer component. Padding 16 dp basically, it'll basically ensure that there's the spacing on the outer sides of the component. Makes the background blue. This is the worst design possible. Don't ever do this. But just so you know, these sorts of things are absolutely possible. Rounded corner shape, things like that, right? So this is just a white text on a blue background, clipped corner radius 8 dp, things like that, okay? This is type safe. This is amazing. So I do have a mini demo, but I do want to say a few things. Just like WASM, WebAssembly, can be a canvas on the front end, technically it can also be a back-end technology, okay? WASI, a variant of WASM, system interface is the last two, right? Basically allows you to write, just think of where you would use like Node.js, like that's the kind of thing you would be able to do with WASI. So there are certain, there are certain platforms that support this kind of out of the box, Cloudflare, being one of them. You can actually write WebAssembly-based applications and deploy them to Cloudflare. You can deploy a web WASM-based Kotlin multi-platform app in Vercel. It's a little bit trickier when to configure the steps, but it can be done. Okay, that's amazing because you're no longer stuck with this crazy build pipeline of so many different technologies to assemble a reasonable web. Okay, where would you use this technology? You would not use it everywhere, and let me tell you a few reasons why. WebAssembly is expensive in the size of the actual assets, okay? So when you're building basic web apps, they're usually very small, like kilobytes or so, right? WebAssembly, a very simple app can be like as bad as 2 megabytes, okay? Not always, I mean, you can optimize to some extent. So let's have a reality check to some extent to everything I'm saying. There is a cost to using this technology. It may be blazing fast, okay? What business use cases might you consider it good for? Okay. Figma, which doesn't require SEO as much, but a very highly interactive user experience that needs performance at the cutting edge. Okay. I'm not saying Figma is using WebAssembly. I'm just saying that sort of thing would be really good for WebAssembly. Okay. Your basic business app, or that's basically not business, your basic like SEO driven website for content, bad use case for WebAssembly because you can't really get SEO with WASM based technologies, okay? But on the flip side, Kotlin Compose doesn't only do WASM, you actually can transpile the JavaScript, okay? So now Kotlin and Compose multi-platform for the web just went into beta. Okay. And they're working on a fallback mechanism. So browsers that don't support WASM will fall back to the JS transpilation. Okay. So you technically, by the way, can even use NPM inside a Kotlin-based ecosystem. So it'll actually come in as a Gradle dependency, and then there's interop between Kotlin and JavaScript if you absolutely need to. Very interesting use case, very strange, but why do I think this is all worth it? It's one language. It's inspired by decades of development, taking the best of functional reactive programming from the React era, but also optimized for both fine-grained reactivity and coarse-grained reactivity. It is crazy fast performantly. It's ergonomic. And this is an underappreciated point. I think it's pleasurable to use, okay? Code that is pleasurable to work with is easier to maintain, okay? Do not underestimate your emotions in software development. They make a big difference on the overall quality of the code. It'll make the difference between you going, do I have to change that? To be like, yes. Let's bring about the best in the code because it'll also bring about the best in you. It is, at this point, supported by most modern web browser versions, but to scale this very quickly, not very practical, okay? Especially if you're worried about binary size, okay? If you're worried about the size of the assets, because again, that has to be downloaded to a person's browser, through a person's browser on a person's computer. That may actually matter, okay? So at that point, this would be a very impractical technology, right? But for an internal tool, it's probably really good, right? If you're building internal tools inside your company, right, where that's not as much of a concern, you can do some really interesting things with this. It's very good. All right, so with that, I'm not going to do the demo because I'm at 40 seconds. But all I'll say is this: like, if you have any experience with Android, this is cake. If you have any experience with React, you can easily adapt to this. If you have Java experience, this is the quickest way for you to get into the front end in a way that's actually manageable mentally. All right, thank you.